Good morning, ladies and gentlemen. My name is Charles Bickham, and it is my pleasure to be here today along my esteemed co-authors, Julie and Robert, to present our work on pre-upload quality checks, efficient bioinformatics file validation in the browser for time and cost savings. To begin, let's provide some background information. What exactly is CZID? CZID is an open source cloud-based metagenomics platform that helps researchers detect and track infectious diseases worldwide. It offers capabilities such as pathogen landscape identification, outbreak monitoring and review, and the ability to identify potential infecting organisms within vast datasets. Now let's dive into the problem. Web applications have emerged as powerful tools in bioinformatics, allowing users to conveniently upload files for analysis on the cloud. However, a significant challenge arises when users encounter delays of several hours, only to be notified that their uploaded data files are not in the expected format or of low quality. This frustrating process hampers efficiency and can diminish user satisfaction as they eagerly await results, only to discover issues within their data files. Fortunately, we have developed a solution to this problem, which we apply to CZID. Our approach leverages the power of WebAssembly, an innovative technology that enables the seamless porting of C, C++, Rust command line tools to the web without the need for extensive rewriting. By compiling CTK and HTF files to WebAssembly, we can execute various diagnosis checks on a small subset of each FASTA or FASTQ input files directly within the user's browser. This allows us to detect and notify the user of any potential issues before the upload process begins. Diagnosis include detecting duplicate read names, truncated files, mismatched R1, R2 read names, and detecting read names that don't match the selected sequencing platform. So now we have a live demo for you. This is an example of an invalid truncated file. This is an example of a valid Illumina file. This is an example of a valid nanopore file. So now the user goes to upload these files, and they selected Illumina as the sequencing platform, and now they're selecting the invalid truncated file. And as you can see, a red error icon pops up along with the warning flag and red error flag associated with these files. The red error flag means that there's no valid files to be uploaded. So now the user selects two Illumina files, and as you can see, the red error flag goes away. Now the user uploads a nanopore file, and as you can see, it gives an error for the nanopore file along with the warning flag. And so now the user is going to switch sequencing platforms to nanopore, and as you can see, now the Illumina files give off errors. And when the user goes back and switches to Illumina as a sequencing platform, they upload these files, and only the valid files are uploaded. For the analysis during the past year, we successfully prevented approximately 3 terabytes of invalid data from being uploaded to our platform. This translates to saving users around 15 days of upload time, considering a conservative estimate of a 20 megabits per second upload rate. Out of approximately 60,000 issues we identified and prevented, 97% were due to users selecting an incompatible analysis type for their input data. For instance, users unintentionally chose the nanopore pipeline while providing Illumina FASTQ files, which would have resulted in failed analysis and wasted time. Additionally, we discovered that around 1% of the issues were related to truncated FASTQ files. Although rare, these files pose a significant challenge as bioinformatic tools often encounter failure when they reach malformed read at the very end. Some of the benefits of the pre-upload QC checks are improved user satisfaction by preventing upload of invalid data. Beyond the benefits to the end users, our pre-upload QC checks have also had a positive impact on our organization's cloud compute costs. By preventing users from proceeding with incorrect files and settings, we have effectively avoided increasing cloud compute expenses, resulting in substantial cost savings. And lastly, by prompting, detecting, and flagging these issues, we have effectively saved valuable time and resources. Looking ahead with the implementation of pre-upload QC checks, we can now infer the sequencing platform and prompt users to select an analysis that aligns within their specific platform. This represents a significant enhancement that was not possible before. We also envision expanding the applicability of our solution to other bioinformatic web tools. Our aim is to transform this proof of concept into a reusable library that can be imported and utilized by other researchers and organizations. In conclusion, by preventing the upload of invalid data, we have saved users time, reduced cloud compute costs, and enhanced overall efficiency. Thank you for your attention, and I welcome any questions you may have.